Now, let us try and see what an indifference curve is. So, take a reference bundle X. The set of all bundles equally preferred to X is the indifference curve containing X. The set of all bundles Y such that Y is indifferent to X becomes my indifference curve. So, what I'm doing here is ideally that I am saying that, I take a bundle X, I take all these bundles with which I am indifferent with X, and all these bundles which provide me the same utility as that of X forms an indifference curve. Now, as we go ahead, you will understand things about the indifference curve. But for now, you have to understand that an indifference curve can be shaped in any way. However, we have a certain shape for a well-defined indifference curve, which we will soon see. It can be shaped like this. 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 All these are indifference curves. But this is how my well-defined indifference curve would look like. And why would my well-defined indifference curve be like this is also something that I will define. So, take a bundle X. I took a bundle of some chips and some chocolates. All such bundles that give me the same utility form the indifference curve of X. Since an indifference curve is not always a curve, its better name might be an indifference set. So a lot of times, as I clearly mentioned, that this may not be a curve. Here it is a curve, but it can be a line. It can be a kinked L-shaped line. It can be a curve which is concave, a curve which is convex. Also, you will see that these curves can be circular, or you will also see that there are different domains that can be like this, like this, like this, whatever. So because, it can be a curve and it may not be a curve at times, therefore, it is better to say that it is not, a lot of times we will not say it to be a curve, but we will also say it to be an indifference set. Now, let us understand what does this mean and how is this happening. See here, this bundle right here, which is X dash, X double dash, and X triple dash are different bundles where we have different consumption of the two commodities. So, this bundle right here shows me different units of X1 and X2. This also shows me different units of good 1 and good 2, or good X1 and X2. This is good X1. X1 can be, let's say, pens. And this is good X2. And X2 can be, let's say, anything else. Maybe, let's say, it can be notebook. Then this tells me that, at point X dash, let's say I consume 1 unit of pen and I can buy 3 units of notebook. At X2 or X double dash, I have 2 units of pen and let's say 2 units of notebook. At this point, let's say I have 4 units of pen, but just 1 unit of notebook. Now I am saying that the utility that I get from 1 unit of pen and 3 units of notebook is same as the utility I get from 2 units of pen and 2 units of notebook. is same that the utility I get from 4 units of pen and 1 unit of notebook, because all these 3 points lie on the same indifference curve. So all points that lie on the same curve give you or fetch you the same amount of utility. Now, let us try and see the first property of the indifference curve. The first property of indifference curve is that any point that lies above the indifference curve. A lot of people ask me, ma'am, why is this indifference curve shaped like this? When I just mentioned that it can shape like anything. So this indifference curve is known as a well-defined preferences indifference curve. Here we are well defining the preferences. Now, what do I mean by well-defined preferences? I mean that one, it follows all of your assumptions of being complete, reflexive, transitive, and also at the same time, this also has a diminishing MRS, something that I will introduce in the coming slides and something that will become more clear as we progress through this video. But for now, let's go back and see the first property of the indifference curve. Any point that is above the indifference curve, any point, it can be above here, it can be here, or it can be here. Any point which is above the indifference curve fetches you a utility which is more than anything on the indifference curve. So I am saying that if a point is here, or here, or here, or here, or here, anything above this, or here, or here, or here, any point above the indifference curve is preferred over a point on the indifference curve. So X is lying exactly on the indifference curve. So any point above indifference curve is preferred over a point on indifference curve. And similarly, any point on the indifference curve is preferred to a point below the indifference curve. So, I am saying that X will be preferred over Y. Okay. So, this means that utility of X will be greater than the utility of Y. That's the first thing. You can also prove this. Think about how will you prove this, and I will shortly discuss this. Now, because of what I just mentioned, I can also go ahead and generalize it in a better way. I can say that any indifference curve which is above the current indifference curve, any indifference curve above this indifference curve will be preferred to this indifference curve. And any indifference curve which is below this indifference curve will not be preferred to this indifference curve. Let us try and understand how we were able to generalize this statement. So, the question that I have for you that I'm going to prove in the next video is the following. Think for a bit and try and prove this. I want to ask, why is the indifference curve 1? Why is indifference curve 1 preferred over indifference curve 2, preferred over indifference curve 3? Try and think about this mathematically.